Hi guys, welcome to determining the magnitude of a vector. So in our first video we described what a vector is. A vector has both, of a directed line segment has both direction and magnitude. So today we're going to talk about how to determine the magnitude. Now the magnitude must be positive because magnitude refers to a distance. It's the distance from the tail to the head of the vector. Okay? So there's two ways to write this. Number one, or to find the magnitude of a vector. Number one, so we'll use absolute value of our vector. V is equal to, it's the distance formula. Okay, that's all it is. You're using the distance formula. So the square root of x2 minus x1 squared plus y2 minus y1 squared. Now this is for vectors that are not in component form. We can use this distance formula. When they're in component form, it's much easier. So if you look on this one, component form, the absolute value of our vector, okay, so it's the absolute value, ensuring that the vector's distance is positive, is just the square root of a squared plus this b squared. So we're looking at these two forms, so we're going to actually do an example of each. Alright, so in this first example, find the magnitude of the vector v represented by PQ, ray PQ, where P is negative 3 to 4 and Q is negative 5, 2. So what this tells me is that the vector is not going through the origin, the tail isn't, P to Q. P starts at negative 3, 4. This is not in component form. So I need the distance formula. So it's going to be that square root of x2 minus x1 squared plus y2 minus y1. I get these values from our order pairs. P is first, then Q. So you have x2 minus x1, so that's why it's negative 5 minus negative 3, that's all squared, plus y2 minus y1, 2 minus 4. So I get the square root of negative 2 squared plus negative 2 squared, okay, which is the square root of 4 plus 4, which is the square root of 8, or 2 root 2. That is the distance, the length, excuse me, of that vector is 2 root 2. In our last example, we are finding the magnitude of the vector v, where v is 2, 5. So I don't have two order pairs. I have a vector that's in component form, meaning the tail's going to the origin and the head is going out to 2, 5. So we're going to find that length. So here's the definition. Okay, the magnitude, okay, of v is equal to the square root of a squared plus b squared. So I wrote the definition. Step 2, I'm going to substitute. A is the first value, B is the second value. So 2 and 5 go in. So then I have the square root of 2 squared, which is 4, plus the 5 squared, which is 25. So it's 2 squared plus 5 squared, all under the radical, which just gives me root 29. I can't simplify that anymore. So that's the distance, or the length, the magnitude of that component vector. Okay, so that is how to find the magnitude of a vector when it's in component form, and when we find the magnitude of a vector when it's not in component form. So if you have any questions or comments, let me know, and we'll see you next time.